Hello everyone, you're welcome to solve this nice algebra problem, which is 8 power 3 plus 8 power 2. This is equal to 36. What is the value of A? Let's provide a solution here. We have 8 power 3 plus 8 power 2. This is equal to 36. Now, let's take 36 on the left-hand side so that we have 8 power 3 plus 8 power 2 subtract 36. This is equal to 0. Now, 8 power 3 plus 8 power 2 minus, we can express 36 as 27 plus 9. This is equal to 0. So here we have 8 power 3 plus 8 power 2 minus 27 minus 9. This is equal to 0. So we have 8 power 3 plus 8 power 2 minus 27, which is the same thing as 3 to power 3. Subtract, here we have 9, which is 3 to power 2. This is equal to 0. Now, we have 8 power 3 and 3 to power 3 here. So, 8 power 3, let's put together 8 power 3 and 3 to power 3. Then, plus 8 power 2 here and 3 to power 2. So, we have 8 power 2 minus 3 to power 2. This is equal to 0. Now, from what we have here, the first part here, this is the difference of two cubes expressed as 8 power 3 minus b to power 3. The second part here, this is in the form of a squared minus b squared. Now, for the first part here, 8 power 3 minus b to power 3, this is the same thing as a minus b. A squared plus a times b, then plus b squared. So this implies that 8 power 3 minus 3 to power 3, this is the same thing as a minus 3. And then here we have a squared plus 3 times a, then plus 3 squared, which is 9. Let's call this the first part. The second part is the difference of two perfect squares, which is a squared minus b squared. This can be expressed as a plus b and a minus b. So this implies that a squared minus 3 squared. Now, a squared minus 3 squared, this can be expressed as a plus 3, a minus 3. So let's call this equation 2. Now, let's combine equation 1 and equation 2. So we have equation 1 as a minus 3. Here we have a squared plus 3a plus 9. Then plus, here we have a plus 3, a minus 3. This is equal to 0. This implies that a minus 3 is common here, so we can factor out a minus 3. So that now, in the parentheses a, we have a squared plus 3a plus 9, then plus, we have a plus 3. And this is equal to 0. So this implies that we have two parts here. The first part is a minus 3. This is equal to 0. The second part here is a squared plus, we have 3a plus a. So this is 4a. Then plus 9 plus 3. This is equal to 12. This is equal to 0. From the first part here, we find that a1 is equal to 3. This is the real solution that we have, the first real solution here. The second part is a quadratic equation of the form ax squared plus bx plus c, this is equal to 0. Now from this quadratic equation, a is equal to 1, b is equal to 4, and that c is equal to 12. Now we have a1. Now, so for a2, a3, we apply the quadratic formula, that's minus b plus or minus the square root of b squared minus 4 times a times c over 2 times a. So let's substitute the values of a, b, and c, so that here we have minus 4 plus or minus the square root of b squared, this is 4 squared, which is 16, minus 4 times a, which is 1, then times c, which is 12. All this divided by 2 times 1, which is 2. So here we have minus 4 plus or minus the square root of 16 minus 12 times 4, which is 48. All this divided by 2. So here we have minus 4 plus or minus the square root of 16 minus 48. 16 minus 48, this is the same thing as negative 32. So we have minus 4 plus or minus the square root of minus 32 over 2. So here we have minus 4 plus or minus. We can express the square root of minus 32 as 16 times 2 times minus 1. All this divided by 2. So this implies here we have minus 4 plus or minus the square root of 16, this is 4. The square root of minus 1, this is I, then square root of 2. All this divided by 2. So here we have that we have minus 4 plus or minus 4i. So this implies that 2 is common here. We can factor out 2. So we have minus 2 plus or minus 2i square root of 2. All this divided by 2. So this implies that we have a2 here. We have that a2 comma a3 equal to, this is negative 2 plus or minus 2i square root of 2. These are two complex solutions that we have. These are two complex solutions that we have, and we have only one real solution, which is actually equal to 3. Now, let's verify that A1 satisfies the equation. Let's verify this. Now, let's verify that A1, which is 3, satisfies the equation. Now, if you recall here, we have that a to power 3 plus a to power 2. This is supposed to give us a value of 36. Substituting 3, we have 3 to power 3 plus 3 to power 2. This is supposed to give us a value of 36. 3 to power 3, this is 27, plus 3 to power 2, this is 9. This should give us a value of 36. 27 plus 9, this is 36, which is equal to 36. This implies that the left hand side, this is equal to the right hand side. And this implies that A1, which is 3, satisfies the equation. So we have 3 solutions to this problem. That is A1, which is 3, which is the real solution, and A2, A3, these are complex solutions, which is minus 2 plus or minus 2i square root of 2. These are also the solutions to this algebra problem. So kindly follow the steps, like this video, and subscribe. Kindly like and subscribe. See you in the next video.